All right, we're going to talk about some special right triangles now. And the first special right triangle that we're going to talk about is the 45, 45, 90 triangle. Now, you get a 45, 45, 90 triangle when you cut a square in half. So it's also the isosceles right triangle, right? Because if you cut a square in half, a square has all equal sides. And if you cut it in half diagonally, you'll end up with a right triangle where the two legs are equal length. And so now let's say we take a square that is 1 unit by 1 unit, right? So each of the each of the sides of the square are 1 unit long, and then we cut it in half diagonally, right? We're going to get the isosceles right triangle with where the legs are 1 unit each. And we can use the Pythagorean theorem to figure out the length of the hypotenuse, right? If you take 1 squared plus 1 squared, you get 2. Take the square root of that, and you get the square root of 2. So the hypotenuse is the square root of 2 units long. All right, now it's good to, starting with that, right, we have our kind of our standard 45, 45, 90 triangle, and then we can use that to look at essentially scale models or similar triangles, right? All of these 45, 45, 90 triangle, 45, 45, 90 right triangles are similar. Okay, so let's take a look at example 3 here, where we have a 45, 45, 90 triangle, and we want to find the missing side lengths in the triangle. So we only know one side length, and so now it's a 45, 45, 90 triangle, so it's the isosceles right triangle. So I think it's pretty straightforward to say that B is equal to 4 if it's the isosceles right triangle. Or if you want to, set up the ratios, we can draw, let's draw our little standard right triangle here, our 45, 45, 90 right triangle. And the side lengths, the ratio of the side lengths are always 1, 1, square root 2, right? That's a 45, what was mark one of these? 45, 45, 90 right triangle. So if you remember the ratio of that of those sides, then we could set up the ratio, right? We could take what the side we're looking for, let's say side B, over the corresponding side, which is 1, and then we also know, let's see, we know the 4 of the triangle in the example here corresponds with the 1 on the other side too. So you could set up the ratios. In this case, again, it's this isosceles right triangle, so it's pretty safe to say that, both of the legs have to be 4. Now to find C, we can set up the ratios. So we want to know C, and that corresponds to the square root 2, right, over the hypotenuse of the standard triangle here, the 1, 1, square root 2 triangle. And then we can take the 4 that we know in the triangle in the example and compare that to the corresponding side in the standard triangle over here is 1. And then if we solve for C, then we're going to get, let's write it here. So we're going to get C, we're just going to multiply both sides by the square root of 2, and so we'll get 4 square root of 2. So that is the length of side C. All right. So so the next example, it says you try it. So now go ahead and try it. And if you want to watch the video, you can watch the video for that. Otherwise, or you can just look at the video and fast forward to the end and check your answer. But I'll go ahead and record that video for you.